Hi, I'm Dr. Peter Leong, and I'll be walking you through the assignment for this course. So first of all, the overview for this assignment portion, um, then followed by the data source, and then the problem statement itself, and finally some deliverables as well as the marking criteria. Right. Now first the overview. Now this particular assignment is supposed to be done on an individual basis, and its purpose is really to give you an understanding of the entire process of applied machine learning, especially for larger data sets than just a typical toy example. So the guidelines is that you are to work on it individually, and uh, you should not be copying each other's work. But of course, you are free to discuss with your classmates or other colleagues as well. In this assignment, you'll be using the convolutional neural network or CNN for image classification, and you will evaluate the performance of that convolutional neural network using a number of measures. Uh, the structure of the convolutional network as well as the hyperparameters are something which you would need to adjust yourself. Okay, so that is actually part and parcel of the assignment. There is no one single solution for this problem, so you need to experiment and try with at least three different types of configurations as well as hyperparameters, so that you have some assurance that whatever answer you come up with is actually closer to the most optimal that you have. So because if you just try one, it's likely that you might actually try something which gives you some amount of performance, but you won't know if it is actually the most optimal result that you can get. Okay, so just let me just turn on the pen. So for this convolutional neural network or CNN, you're going to configure it to for the image classification. Now, you of course you need to also determine what is the input size that you want, right, based on the images that you receive, as well as determine what is the output size that you need based on the number of classes or the outputs that you need from this convolutional neural network. But the number of in hidden layers that you need, the number of neurons that you need for each hidden layer is something which you would need to determine yourself, because there is actually no fixed formula for determining those things. And lastly, for evaluating the performance, this is actually very critical in a real project because you don't know if your evaluation is going to be just examined by another data scientist who may want to replicate your work, or it's going to be actually even presented to business holders. So you should think very carefully about how you are going to evaluate your work, all right, so that it can be presented to different audiences. What is the level of assurance that the results are actually correct? You would probably want to think, first of all, from a technical point of view, right? Another peer who will evaluate your work and try to replicate your result. But also think about the presentation of those results to the business stakeholders who may not understand the technical jargon, but they need to know like what is actually the impact of the predictions that are made by the model in the context of the real world problem. Then in terms of the deliverables or output, you are required to do your work in a Jupyter Lab or Jupyter notebook, and this notebook should include all the self-documentation, right? Not just the output of the code execution, but also the markup cells to document how you interpret the results, etc. And yeah, comments, visualizations to make your code and work understandable would be quite critical in the actual marking of your assignment itself. In addition, please save a copy of your notebook as a H or export it as a HTML file, so that it will make it easier for us to evaluate. And also actually it's a good practice because you may not be able to run the notebook all over again from the beginning whenever you want to present your results. So saving it as a HTML file, which basically caches or stores the result already without having to rerun the whole notebook, will save you a lot of time, and it's also a way of record keeping. So the IPYNB file, as well as the so-called saved HTML file containing all the results of your notebook after it's been executed. And to just help us to understand what are the highlights of your project, imagine if you are going to present this not just to another technical audience, but even to business stakeholders, do create a slide deck using PowerPoint or using Google Slides for your project. Okay, and you probably want to highlight only the most important points in your presentation file rather than trying to duplicate everything that's in your Jupyter Notebook. And remember to submit your Jupyter Notebook, the data, the slides, etc. as a zip file at the end. The data, if it's too large, you may want to send it as a link to the final result. But typically, when we submit any work in data science, we need to account for what is actually the data being used, so that the people who actually look at your results can actually try to replicate parts of it and verify that this work was actually properly done, right? So, but I know that the data set that you may be getting is kind of large, so you may not be able to submit it electronically as part of the zip file itself, but provide a link to a drive that we can actually access this zipped up result. I mean the data files, so that we can actually verify that the notebook together with the data gives you the consistent result. Lastly, students are also required to submit using your online tools. Okay, so don't submit your results using something that can only be executed on your own laptop itself, and not provide us any of the tools as well as the links that we can actually try to replicate those results, so that we can verify your work. Please remember to include your name and your student email at the top of your Jupyter Notebook, so that we know who is it from, or class, etc. Okay, all the reference information that you need, course name, module name, etc. And as well as in the titles slide of your PowerPoint deck, so that we know that who is actually creating this particular PowerPoint. Now, the last part is actually covered. Let me just hide myself a bit. Okay, so importantly, the normal rules for copyright and plagiarism apply. So we are not stopping you from referencing any materials out there, but please be mindful that referencing other people's work and claiming that it is your own is basically what is considered plagiarism. Now, this could be your own work as well, or your classmates' work, as well as work that's available on the internet, that's actually being shared on Stack Overflow or any other websites, or as a blog in Medium. You are free to reference and take a look at their work, because we don't want you to reinvent the wheel. But if you do reference their work, please include it as a link with the complete citation inside your notebook itself, so that we know that you have referenced somebody's work, you've given them due credit, and you are not infringing on their copyright, right? And also, you're not claiming that this work is your own, right? You're just referencing their work, and you may actually build on top of their work, and I would encourage you to do so. Make some comparison, like what did this Mr. So and so did, and how did you evaluate it, and maybe you have made some changes to the hyperparameters, or you have only copied one portion, like maybe the way they have done the feature encoding for that particular project, rather than actually duplicating the whole thing as your own, which is basically plagiarism. So referencing is fine, but do try to put in your own contributions, because you'll be evaluated and given marks based on your contribution to the problem rather than how much you can copy from someone else. Okay, so please cite all sources, source code, examples, blog sites, papers, etc. when you submit your work, because a lot of students have been caught in this aspect. Plagiarism is a problem in the digital domain because copying is the most natural thing and it's so convenient in the digital domain, but for academic assessment and academic purpose, we need to have some sort of discipline. So we don't stop you from trying to improve things that somebody else has done, but please do not claim it as your own work when you have actually referenced their work and actually taken quite a bit of material from their work. So you can refer to it, you can even replicate some of their work, but do try to improve it or make a contrast or comparison between this work by Mr. A and another work by Miss B, and what is your own contribution and as compared with A and B's, right? Maybe you have compared the two and you find that, hey, actually based on your evaluation, B's work is better. That comparison itself, showing that B is better than A with a certain particular criteria, is actually your contribution, because nobody may have done that comparison before using those parameters. So that's actually your own unique intellectual contribution. So you are free to do that, right? You don't need to reinvent the wheel. Let me just say again, but it's important to cite or reference correctly using standard citation formats like the IEEE format or Chicago, or even the APA or MLA formats. Okay, so you can refer to any of the standard citation formats. Okay, just make sure that you cite all your work properly, and then you are safe, right? Then you will not be guilty of plagiarism. But on top of just citing, just remember to really highlight what is your contribution over and on top of their work, right? Because if you just cite and then just still copy wholesale, it is still basically copying, and you will not be given any credit for just copying somebody else's work. Right, so I think that would be the main thing I want to talk about in terms of the background. So just to repeat, you are to do this work on your own, and you are to create the architecture for the neural network yourself. You can reference people's work to see what are some of the great architectures that have been tried before, but you should actually try to evaluate and come up with your own parameters and your own contribution to make the results even better. It could be quite a important contribution, like changing the algorithm, or it could be even a rather simple contribution in terms of actually selecting the most suitable image input size, given the many examples that you have. Okay, so that really depends on the problem, and you will understand what I mean as we jump into the problem itself. And also I just explained to you some of the other nitty-gritties of submitting your results with the necessary format for evaluation. Right. Thank you very much. And in the next section, I'll talk more about the data set itself, as well as the problem that you're trying to apply the data set and the model to. And I'll see you later. Thank you.